સવાલે નહીં આવતો ગ્લાસ ભરીને દે મારે મને લોકો કનેક્ટ કીધું પૂએ સેશન વટાથી ને હું જે સેટિંગ જ કરું રહી વટે ay ma
very good morning, everyone.
Good morning, ma'am.
Yeah, yeah, yeah. Thank you for joining the session. We'll be starting the session in 5 more minutes. Manoj sir, Manoj sir, am I audible?
Yeah, I'm audible.
Yeah, yeah, sir, you're audible.
Okay.
Sir, we'll wait for 5 more minutes
No
and
issues,
we'll
no
start.
issues. I'm doing just setting of my camera.
Okay, okay,
I'm doing setting of my camera. I'm audible correctly?
fine. Yes, sir, you're audible, sir.
Okay, fine, fine.
Good morning, everyone. Um, Once again, I welcome you all for today's webinar on Raspberry Pi and its applications. I request Shruti M, Assistant Professor, Department of Electronics and Communication, Vienna Institute of Technology, to welcome the guest. Thank you.
Thank you. Good morning, everyone. I, Shruti M, Assistant Professor, Department of Electronics and Communication, Vienna IT. I take this privilege to welcome today's speaker, Manoj Kavedia. He is working as Assistant Professor and has 23 years of experience in teaching. His field of interest is embedded system IoT. He has done many research on IoT and its application and also the implementations of Raspberry Pi application. And he has won several state level and district level prizes for the work that is being carried on, like PC based greenhouse, AR based control system, PC based gate control system, flame relay, PC based dam security system, controlling devices with thoughts using the brains itself. So I take this privilege on behalf of management KRG and from Dr. Vijay Singh Reddy, Principal Devana IT, and Dr. Chandrasekhar SM, HOD ECE, and all the faculties of Department of ECE. I welcome you, sir, once again for today's session. I request Manoj, sir, to take over the session. Thank you, everyone.
Thank you, ma'am. I hope I'm audible.
Yes, yes, sir, you're audible.
Acha, one more
You
thing.
can share the screen.
Yeah, I'll share one more thing I would like to say. I'm even logged in from another device. Is it camera on? Is that device visible? Can you just check?
Camera is not on, sir.
Uh, One sec. I've logged in from two
You can
devices.
on it.
No, no, no. Yeah, I'm
Okay.
just trying. Now
Yeah, camera is visible, sir.
visible. Fine, because even I want access of that camera also. because it is not seen on my screen. Is that camera visible to everyone? Yes.
No, sir.
Yes, sir,
No,
it's
sir, it's not
visible.
available.
Can you see the hardware setup? Just a moment, I'll switch over there. Can you see the hardware setup?
No, sir.
Yes, sir, it's visible, sir.
Acha, can you make this my camera as also host, a part of a host, so that it will be very easy for me for demonstration actually.
Sir, I should make that.
Yeah, yeah, yeah. That is also part of a host, so that it can I can switch over to that also whenever needed.
Yes, sir, I'll make it, sir.
Yeah, actually I tried with IP camera, but there is some net issue over here. Because of that, that IP camera is not getting connected. So now is it visible? Uh, have you made host?
Yes, sir, I have made the master as a presenter. You can continue now, sir.
Okay, fine. Just a moment, I'm getting connected. Is it LED visible to all? Yes,
Sir, it's visible.
LED part is visible. How many of you can see this LED part? Can you just please? Okay, LED is visible now. See, this is what is my hardware setup. If you can see, how many of you cannot see?
It's not visible, sir.
I'm just now is it visible? Yes. I have shared the screen from my. Is it visible now?
No, sir.
Because I have shared this.
So the screen is not visible to us. Not visible.
Just a moment. I'm just checking.
Sir, can you refresh the screen? It's not visible to anyone.
Just a moment. I'm checking. Have you made my cell phone as also host? My another this phone. Now is it visible? Now is it visible? Yeah. Now it is visible. Correct. Okay, fine, fine, fine. Great. So this will be one of my screens. Fine. To which already I have connected one PIR sensor. And see, for today's presentation, it will have two or three parts. First, I'll be giving a brief introduction of IoT, then something about Arduino, and then something about the other part of Arduino, I'm sorry, Raspberry Pi, and then finally one demonstration with Raspberry Pi. So I hope you can see this screen here. Fine, I'll be moving camera afterwards. This is my Raspberry Pi setup over here. I hope.
Can you please let me in, sir?
Uh,
Still I'm waiting, sir. Yes, ma'am.
Now see this. Can you see this setup? Everybody?
What, sir? No, sir. Nothing is visible, sir.
To others, those who are connected, can you see?
I'm in waiting room, sir.
Visible, sir.
Yeah. Please, the coordinators just check those who are in the waiting list. Please take them in, or they will be.
Yes, sir. Yes, sir. Your screen is visible, sir.
Okay. Now everything will be clear now. Just a moment. Now in this screen you can see I have connected Raspberry Pi. Fine, and this is my touch screen. But see, to this device I have not connected the keyboard or mouse. Can you see that? I have not connected any keyboard or mouse to this device.
Sir, sorry for the interruption.
Yes.
Just a minute, sir. Dear participants, please click on the window Manoj Kavedia. Please click on the window Manoj Kavedia. You can see the screen.
Because at my end,
What sir is sharing? You please. There are two names, right? So in that, please click on Manoj Kavedia. You can see the setup.
yes, is it visible now?
Slide share.
Yes, the screen is visible now. Yes, Priyanka madam.
Yes, sir. It is visible, sir.
Okay, to have
All the participants also it is visible, right? No, sir. It's not visible. You can see the screen. We can see that Pi board and all.
yeah, because from my end it is visible.
It is visible, right? Yeah, yeah. Thank you. Yeah, thank you.
See participants.
Sir, I hope, I think you can continue now, sir. Yes, sir. Yes, sir.
Hello, ma'am. Hello.
Yes, sir. Continue, sir.
Again, even if I speak with hello, it's audible, ma'am.
Yes, sir. You are audible, sir. You are audible, sir.
Even if I entering with resource person details, also it is not entering with. So the screen is not visible, ma'am. Resource person presentation screen.
Sir, not yet started the presentation. Sir is showing the board, sir.
I'm just first of all I'm telling you.
Board and all and sensors, various sensors we can see here. So you please click on Manoj Kavedia window.
Participants, I have logged in with two windows.
You can see the screen.
Participants, I have shared with two windows because one on one I'll be showing the hardware setup and from another I'll be showing the presentation. So now I think it is visible to all. Yes, participants. Okay, fine. Now if you see this setup, see this LED is connected, one PIR sensor is connected, I'll be telling you all the details afterwards, just for interest, like what exactly we'll be good doing today. I'm just explaining you. Fine. So you can see there is one LCD screen over here. Fine. And there is a Raspberry Pi, but I have not connected any keyboard to it. I have not connected any keyboard to it. It is connected wirelessly without any keyboard or mouse, and this I am controlling through my computer. Fine. So this is one of the nice example of IoT, Internet of Things. See, now you can see clearly the Pi setup of mine. In that there is one LCD screen. Fine, there is no keyboard or mouse, but I'm doing some activity which you can see on the screen. See, I'll just click here. You can see some of the activities which will be happening on the screen now. Fine, it will take some lag is there in the network, so it may take some time, but it will be visible on the screen. See this, now it is visible. You can see some activity which has happened. Some menu has been turned on. So this is one of the simple example of the IoT, Internet of Things. I have connected my Raspberry Pi using Wi-Fi. Okay, using Wi-Fi to the computer, to my computer. So I am controlling this Wi-Fi wirelessly. This is one of the nice example of what you can say is the IoT. Now today's presentation, first I'll explain you what is IoT, some history of IoT, then what are the different boards we can use for IoT, then we'll jump to Raspberry Pi, and after Raspberry Pi, fine, we'll be going to the details of Raspberry Pi 3B plus and two simple Python programs, one for blinking the LED and one for this sensing of the human being with the PIR sensor. So this is what we'll be doing today. Fine. So I hope it is visible now to everyone. Have you seen the setup? Okay, fine. So now let's start with a presentation of Raspberry Pi. Okay, I'm sharing my PPT, just a moment. Fine, is this PPT visible?
Dear participants, kindly mute your audio, please.
Yes, ma'am. Is this PPT visible? It's Internet of Thing and Applications.
Yes, sir, it is visible, sir.
Okay, fine. So friends and participants, good morning to all, and just I'm sorry because of the small network issues and the settings, and this will happen because we are all at different part of India right now. Well, what we are communicating with each other, like when I'm talking to you, you're talking to me, your ma'am is at some other place, teachers are at other place, HOD is at other place, not other place means you may be within the Karnataka, but then the geographic locations are different. So how we all are connected, that is one of the nice examples of Internet of Things. Fine. So let's see what is Internet of Things first. So this is what is the target for today. We'll see Internet of Things, different hardware, Raspberry Pi, programming of Raspberry Pi, and then we'll see LED interfacing, and then PIR sensor, and some diagrams or images of automation systems, which you can take up as your projects in the for the years. Now, very first thing, Internet of Things, IoT, what it is? It's a network of physical objects or things. Now these objects can be sensed and controlled remotely. Now one of the nice examples which I've shown you, that how I'm controlling my Raspberry Pi. My Raspberry Pi is at some other part and I am controlling that. Fine, that is one of the example of IoT. We talking to each other, IoT, we are remotely controlled. Now the coordinators who are sitting at your end, they can control my screen, I can control their screen if I'm a host. So this is one of the nice example. So IoT allows object to be sensed and controlled remotely across the existing network infrastructure. Fine, creating opportunities for direct integration between physical world and the computer based systems. And why it is
Yes,
done?
sir.
Yes.
Sorry for the interruption.
Yes ma'am. Yes ma'am.
Sorry for the interruption, sir. Can you make presentation means can you make PPT in presentation mode?
Ma'am, I already taken in the presentation mode.
No, it is not there, sir. Can you
I'll
see
just
again?
check, just a moment. My PPT is already in the presentation mode.
Enlarge the screen.
I might have not been refreshed. Now it is okay. Is it okay now?
Yes, now it is. Okay, sir.
Fine. Just a minute, ma'am. I think PPT is clearly visible now. Just give me a moment. Actually, there is a lag in the network since morning today. I'm sorry for this. Now PPT visible?
Yes, sir. It is visible, sir. It is visible. It is visible.
Is it changing? Has the screen changed?
No, no, sir.
It's not refreshing actually. Now the screen has changed. That is changing now, correct? Yeah. Now it is okay. I'm checking from my end also.
Can you take one of the slides, sir?
Now it is visible clearly. I'm sorry, participants. Just
Go to the next slide, sir.
yeah. I've
Yes,
now
yes,
taken
sir.
the next
It is
slide.
changing now.
Yes, sir, it is visible, sir.
But slide has changed now.
Yes,
Your
things.
PPT is visible.
No, I am on the 1982 ARPANET.
So we can see this slide, sir. Internet of Things. Uh, things is in red color.
Array, it is some issue with the Teams actually.
It's
It is not
green.
refreshing. Not refreshing. It is not refreshing actually. There is an issue with Teams.
Sir, and your audio is too low, sir.
Audio is low. At my end, it is properly audible. I'll just share it once again.
No, sir.
Actually, there is an issue with Teams, I think.
Let it be, sir. If you are writing now, it is visible for a fact. No issues, sir. If you go to the slide, sir, it is, I think it is giving problem.
No, ma'am. Actually, issue is there is some issue with the Teams. It is not refreshing the screen actually.
Yes, yes. Correct.
Team is not refreshing the screen.
So, sir, you can
Yes.
present like this only, sir. We can. It is visible. So now we can visible this slide 3. So let it be like this only. So if you change it to slide 4, we can see that. Like
Okay,
this.
fine. For a moment, I'll change it to slide 5. Is it slide 5 visible? Slide 5 is
No, sir.
1982.
So still
Yeah, it is.
it
It
is
is not
showing
refreshing the
1982
screen.
itself.
It is not refreshing the screen. Actually, the issue is that it is the issue with the Teams, I think.
Yeah, sir. Now it is changing, sir. You can start the presentation.
Fine. So we were at the point. Participants, I'm really sorry. This is a network issue. So we were talking about Internet of Things. So I've told you that Internet of Things is an basically the network, or you can say it's a network of physical objects. I've given you a nice example that I've connected my Raspberry Pi. Fine. This Raspberry Pi and hello, please participants whose mics are on. Participants, I'm really sorry because there is some issue with the Teams only. Ma'am, hello.
Sir, is it possible to?
Ma'am, what I can do very simple thing is I can divert this presentation on YouTube. Hello. Do I'm audible, ma'am? Hello. Madam?
Sir. Yeah, sir.
No, actually Teams is giving a issue. Teams is crashing here.
Okay.
Just a minute. I'm calling Priyanka, ma'am. I'm sorry, participants. I'm really sorry for this technological fault. Hello. Priyanka, ma'am. Actually, team is giving an issue. It is crashing frequently. I don't know why today. Yeah. So what I'm doing is, shall I divert that my presentation on my channel so that participants can view from the channel itself? And I'll give you a link within 2 minutes. No, ma'am. Actually, see, thing will be when I say and the screen is not refreshed properly, thing will be an issue because at what slide you will be and at what slide I will be. So I'll do one thing. I'll disconnect the Teams and I'll divert my presentation to YouTube and I'll share my link of the YouTube right now. So you can connect through YouTube. It will be very smooth presentation. Fine. Yeah, fine. Thank you. Yeah, thank you, ma'am. Thank you very much. Thank you. And just give me 5 minutes. I'll just divert the things to the YouTube.
Dear participants, sorry for the inconvenience. We will sort out this issue in 5 minutes. Please wait.
Hello. Hello. Yes, ma'am. Yes. Ma'am, actually problem is issue is at our and I think so because of this thing and there is a presentation having work that is disconnected. That was the issue. So either I can share, there is no issue with it. The thing is, it is giving a fluctuation since morning. Actually, this is happening. It is getting connected, disconnected, connected, disconnected. So my OBS software will take care of it. Actually, software can do it properly. But that thing is getting a problem. It's getting disconnected. So this is operational maybe. I'll give within 5 minutes a link for YouTube. Everybody can join the YouTube. And it will go very smoothly. The presentation will go very smoothly. There won't be any issue. Yeah, 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 yeah. And what I can do, even, yeah, and what I will do. हेलो मैम। मैम लेक्चर चालू है, मैं लेक्चर खत्म करके आपसे बात करता हूँ। Yes, participants, I'm audible now. I hope audio is clear to you now. If my audio is clear, please just write yes so that I can start. Do I'm audible, participants? Okay, fine, fine. Very great. Okay. So I hope now it is audible to everyone, and I think the session will go smoothly now without any interruption. Okay, fine, fine, fine. Thank you very much. And I'm really sorry for the things which has happened because it is a technical glitch which I cannot help. But then I'm trying my best to continue with the session without any interruption now. So friends, let's start with the session. And we were talking about Internet of Things. And now what is Internet of Things? A nice demonstration which I've given you. Now we have seen two part of it right now. That is one of the advantage, that if the network is smooth, how the things will go nicely. And the another part is how the session has been interrupted because of the issue of net. So this is like the things what basically we need is a smooth internet for the session to go smoothly. So now let's continue with the things, and let's see the presentation. Again, I'll be starting. I'm just telling you about, I've told you about the Raspberry Pi. I've shown you the Raspberry Pi, and that Raspberry Pi basically was connected to my PC with a remote access, and I can control from my end. I'll be giving you that demonstration. I'll be showing you the LED blinking code. But prior to that, let's see in short about what is IoT. So this was the thing which we were supposed to see, that is Internet of Things, and then different hardware, Raspberry Pi programming, LED interface, then project about one a simple project about LED and PIR sensor, and then some few images of the things. So now what is Internet of Thing? So Internet of Thing, basically it's a network of physical objects or things and embedded with electronics. Definitely when the physical objects or network comes, there has to be an electronics, and we'll be having sensors with that. So all the sensors, and so I hope I'm audible properly. Now IoT allows the object to be sensed and controlled remotely across a network infrastructure. Now two examples are here. One example is I've shown you the controlling of my Raspberry Pi, which was controlling through the network. That are two remote objects. And secondly, we all are communicating with each other. Fine. And when we are communicating with each other, it is, we are at the remote locations. We have some existing infrastructure, that is internet. Just imagine for just 5 minutes or 10 minutes, our Prime Minister Modi ji decides that there will be no internet around India. You can imagine what will be the today's scenario. We cannot connect it, we cannot get connected to everyone. We will be physically connected but even isolated. Fine. So we should have some existing network infrastructure. And what it is doing, creating an opportunity for more direct integration between physical world and the computer system, and resulting in improved efficiency, accuracy, and definitely the economic benefit. Previously, a teacher and student were contact in physical contact with the classroom or a college, But today that barrier has been reduced. You are sitting somewhere in another corner of India, I am in another corner of India, and definitely we are talking to each other. So that is what is efficiency, accuracy. But the only thing for IoT is the network should be very, very, very stable. If the network is not stable, then there is an issue. And now soon we'll be entering in 5G world. And when we'll be entering in 5G world, definitely the speed, definitely the cost of the network will, or the cost of the usage of the network will get reduced. Coming to the next part, that is things. So things in IoT sense can refer to wide variety of devices. Now it can be a air conditioner, it can be a refrigerator, TV, a household applications. We are using Ola and Uber because two devices are communicating. Nowadays many chips, biochips, transponders, RFID things are connected to the human body or the animal bodies. They are also becoming a part of the IoT. So what these do, these devices collect the data, and some sort of analysis is done on that data, and that analysis will give us some result. So let's see when this actual IoT started. So in 1982, first Coke machine was connected to ARPANET. ARPANET was 8-bit network. First, in what you say, the local network was ARPANET. Fine, it was connected in 1982. So in 1989, World Wide Web, Tim Berners-Lee invented World Wide Web, and the total scenario of connection was changed. So after that, in 1990, the first IoT device was a toaster. So it started in 1982. Fine, that was a Coke machine, and after that, in 1990, a toaster was connected. Then in 1993, X Coffee is created. That is at the laboratory of University of Cambridge. Then in 1994, a wearable internet connected camera was designed. Fine. Then in 1997, the first symposium was there on wearable computers. And then in 1998, there was an introduction of IPv6. Today we are using IPv4 as well as IPv6. And I hope you students know what is IPv4 and IPv6. So it is a protocol version 4 and version 6. In 1999, Kevin Ashton introduced the term Internet of Things. Actually, he was working with RFID. Now, here RFID doesn't mean that the card which you're using is a RFID card. But here the RFID means anything which is identified remotely. Now, any device which is connected to internet has some unique ID, and that ID is nothing your IP address. And we are connected with radio frequency source. Okay, that's why we call it as RFID, radio frequency identification. Please don't get confused with what is the RFID we are using for the credit cards or the debit cards or the smart cards. It's not that RFID. That's a part of the RFID. So he was a person, Kevin Ashton. He is also called as father of internet. Then in 2000, smart refrigerator was announced by LG, but because of its cost and the problem, it couldn't gain that much popularity. Then the term Internet of Things first appeared in book in 2004. So you can imagine the things first connected was in 1982, and first time the term appeared in 2004. Means it's just 16 years down the line. Then in 2005, Knapsack was manufactured, and it was the first personal assistant. I hope you may be knowing that it was Knapsack. It was first personal assistant. Now today we have a lot of like Siri or Google Assistant or many more. Then first international conference in 2008. Then in 2009, everybody knows a self-driving car was announced. And after that, China picked up this industry. Today, China is the biggest manufacturer of the sensors. Fine. When I started my working in IoT long back, around somewhere in 2001, 2002, I used to purchase sensor which were costing 3 to 4,000, and same sensors today are available at just 3 to 400 rupees. That is what is the difference what China has created. but then now it is taken over by India also. Many of the things are being uh, developed in India. So India is going well, and many other importers are also available for the sensors. Then in 2013, Google Glass was announced, and this year even Jio has announced the Google Glass. So the moment 5G will be starting, as soon as the 5G starts, you know, the complete scenario of looking towards the internet, towards the mobile internet and moving objects and all those things, and IoT will change the face. And it is expected that till 2020, when it ends, there will be 50 billion devices which will be connected to internet. So you can imagine, when I say 50 billion devices, those devices are to be manufactured. For manufacturing those devices, programmers are needed. For hardware, developers are needed. The person who do the integration of hardware and software, those are needed. Definitely the working who are working with the security, those are needed. So there's a big potential in this particular field. So this is a hot cake now, and students, there will be lot of job opportunities in the field of IoT. So being an electronics and telecommunication engineer, fine, there is a large scope. If you're good in any field, if you're good in the programming field, if you're good in designing field, if you're good in marketing field, all these fields can be clubbed. In which you are good, you can go as an take an opportunity, and you can go ahead in the life with the career of that. Then in 2014, so the number of devices exceeded the number of people. So that was the scenario of 2014, and even today people are more, definitely, but devices are also more. And in 2015, the global initiative on Internet of Things started, and it is going on now. One such demonstration I would like to give you, which in the terms of PowerPoint, that what happens if water start logging, like it's just I've shown with animation. Now see, there is a server, there is a machine, and there is a internet, fine. And this is connected to antenna. Now this is small moat, and this moat is basically, do I'm audible, everybody? Okay, fine. Okay, now in this presentation you can see there is a moat. Now this moat is a MEM, micro electronic mechanical system. On that small moat, it is like a small rice, like a small pearl, okay, or a pulse. In that, there is a transmitter, there is a receiver, there is a sensor, and many more things. Now such moats I can sprinkle on the shore, and when I sprinkle on it on the shore, what will happen? It will try to connect to gateway. It is self configuring. So once it get connected, it will try to connect to all the nearby modes. So once it is getting connected to all the nearby modes, what will happen? They will create a network of it. And once the network is created, fine, if there is a barrier, that mode cannot communicate, but other modes will get communicate, or getting the communication path through. And now see, one of this example here, this mode is not connecting because there is a barrier in the communication. Now see, all this network is ready, the complete system is ready. You can see one by one there's a communication barrier, and now my sensor field has been created, fine. So now what will happen is, when if there is any water logging over here, these modes will try to communicate with each other, and they will give a message to the server that, boss, there is something wrong, water started logging, so you please try to take preventive measures. So see, these sensors are checking for the water, and when this water will be logging here at one end, what will happen is, every sensor will try to communicate, they will make a path, and after making a path, they will try to get connected to the server, and then server will send a message. Now see, if there is no facility of internet, then this thing won't be possible. So this is one of the nice example. Now such type of systems can be put in the forest also to find out the exit point if there is a fire breakout. Okay, any disastrous things, this type of systems can be used. Now I've already told you that in 2003 500 million devices were connected, but till 2020 there will be 50 billion devices. So what it is doing, change is only the permanent thing in the world. Fine, every time we have to change, and internet is doing that. Fine, so you can see what's the potential and what is the future of this IoT. Now what basically IoT does, it takes the data. From that data it will extract the information, means the only important data it will keep, rest all the things will be discarded. And then it will take some sort of decision that what exactly to be done with that data, and then it will give you some experience. I'll give you one example, that suppose uh, in Bangalore, suppose if you're traveling from, let's say, area which I know which is Chickpet to the airport, and let's say this is your daily traveling, and your traveling is being recorded daily. Now suppose if you started moving from Chickpet in Bangalore, and suppose you reach at some 10 o'clock at some point where there are food joints, so your information is collected that you are near the food joints, and you will start getting a message that nearby these are the nice food joints and you can get this nice type of snacks. So if you're hungry, you may get into that food joint and you can take a food. Fine, so see, the data is collected, information is extracted, and a knowledge is created that you are at this point. Fine, if there is nearby any sale going on, and if you are a hobby savvy person, then you can take the, go to that particular what do you say, the sale shop, and you can collect the material. So that is what the things are done. And then once you go to that food joint, or you can purchase anything, you get a message what was your experience. Now you will rate it at 1 star, 2 star, 3 star, or 4 star, or 5 star. And whenever next time somebody else try with the same thing, he will first see what is the experience of the people, and then he will try to get into that particular food joint or the mall. Even rather we do, when we try to purchase any product, what basically we do, we basically try to see the experience of the people who have already taken, we see the star rating, and after star rating only we go ahead. So these are some of the examples, that is waste management. You can see there is a cloud in between, there may be different sensors, a moving vehicle, and a different recycling plant, or the council, city council, and the health authorities. So see, this truck can have a garbage, and that garbage will give different sense data. Now if the product is useful for the manufacturing plant or the recycling plant, that particular product will be transported there. If there is some rotten things or some wrong product in that, health authorities will get a message. Fine, and daily transportation information will be given to city council. So things will be properly managed. Then this is the shopping scenario. Even when you go to mall, you are being tracked every moment, in which shop you are there, what product you are buying, everything is recorded, because a cell phone is there in your hand, and that cell phone is tracking you with the everything. And this is integrated with the internet banking. So internet basically helps in interacting with each other. We contribute, interacting means I'm talking to you, I'm contributing some knowledge to you, and if I try to purchase something, I can do the payments with the help of the online systems. So that is collaborate, many different things are getting collaborated in between, maybe a shopping mall, maybe myself, maybe my vehicle, maybe a petrol pump, as well the banking system. So I did not have to carry the physical money, I can work with my plastic money. Fine, so I hope the things are clear, and I'm not boring you anyone. This is just to build up the scenario. Now we'll go towards the hardware which can be used. Fine. So very first hardware what I'll be explaining you is Arduino. Now Arduino is an open source platform. Fine. Open source means many of us can contribute, and we need not have to understand what is the architecture of it. I want just the knowledge of what is my input and what is my output. But and the programming language. That is what all needed. Fine. So what are the features of Arduino? It is simple to build. Fine, it is at low speed, it is working around 16 megahertz. Then there are some GPIOs, general purpose input outputs. Fine. Then there are some PWM pins, that is pulse width modulated pins. There are some analog to digital pins and many more. So you can see here for an Arduino, on this one side, fine, there are pin mentioned from 0 to 13. There are digital pins which will work with zeros and ones. On the other side there are A0 to A5. Those are analog pins. They can be interfaced with analog sensors. This can be interfaced with digital devices. And when I want something like speed control or something like intensity control, then I can connect them to PWM pins. So pins like 3, 5, 6, all are PWM pins. So now you can see this is the complete Arduino. Here these are the digital pins. This is serial communication. So this Arduino can become one of my sensor point which can give me information, and I can connect that Arduino to the internet. Fine. For this Arduino to be connected with internet, I required one module which is called as ESP8266. I'll be showing you further. Why I'm telling you this, the reason is, what is the benefit of using Raspberry Pi over these components? Fine. So this is the Arduino which I have told you. Then the second component is Node MCU. Now the benefit of Node MCU is it has digital pins, it has analog pins, but the very important feature is it has built-in facility for Wi-Fi connection. It can be directly connected to Wi-Fi because it has built-in Ethernet module. The module which you can see on this is a Wi-Fi module. Now you can see here, these are the two modules I have shown, ESP8266, and I have shown a Wi-Fi module. Now this ESP8266 I have to connect to Arduino, and this Wi-Fi module is already built in on Node MCU. Now if I build any sensor with Arduino, I have to take Arduino which is costing around 500 rupees. Then I have to take ESP8266 which is costing around 250 to 300 rupees. So one set of cost will become 500 to 800 rupees, sorry, 800. But then if I go with Node MCU, it is costing just 450 to 500 rupees. So my Node MCU can become a nice sensor product. So the demonstration which I've given of the seashore, okay, the red dots, this red dots can be small product from Node MCU. So you can see this is Node MCU. Okay. So everything for a sensor to be built up, that is available on Node MCU. Now Arduino and Node MCU both are working at very low speed. So what we do basically, we go with something which is called as Raspberry Pi. Now what are the features of Raspberry Pi, which is our main topic for today? Now in Raspberry Pi you have a CPU, a RAM, extendable memory. I can connect SD card which can be from 8 GB to 32 GB. Fine. And it is working on Raspbian. Fine. That is a default operating system which is the distro of Linux. It has IO pins also. You can see there are some IO pins on the top. Fine. There are some IO pins. Now to this IO pins, these are 40 pins to which I can connect the sensors. Now apart from that, what are the different things we'll see on the Raspberry Pi? So what is Raspberry Pi? Basically it is a small single board computer developed in UK by the Raspberry Pi Foundation, and it was basically to promote basic computer science in the school, but now today it is used for many different purposes, and we call it as a credit card size computer. We call it as credit card size computer because it's very small. Fine. Now today what Raspberry Pi we are using is 4B, which was invented in 2019. This is the evolution from present to the past. Then Raspberry Pi 3 came in 2018. 2017 there is Raspberry Pi 0. 2016 there was Raspberry Pi B 3B. 2015 there was Raspberry Pi 0. Then in 2015 Raspberry Pi 2. 2014 there is Raspberry Pi A plus and B plus. And the first was Raspberry Pi Model 1, which started in 2012. So in 2012 to 2019, 7 years down the line, only 7 years old is the Raspberry Pi. So it is the latest technology. And maybe within a year or two, we'll be getting Pi tops, Raspberry Pi laptops. Even you can see, if you take the version 4, you can see the memory capacity. Version 4 is working around 1.4 gigahertz, and it has 1 GB, 4 GB, and 2 GB models. So even our PC, we are having 4 GB of memory or 8 GB of memory. So if Raspberry Pi comes with 8 GB, it will work like a standalone computer for us with a very small resources. That is what is the benefit of using Raspberry Pi. Now, as compared to the Arduino or Node MCU, why Raspberry Pi is preferred? Because Raspberry Pi has its built-in operating system, and to that operating system, fine, I can write a program in Python and I can work with that. Now, if I want to connect a sensor network or make a sensor network, I cannot use one Raspberry Pi for one sensor. So I'll take a main system as Raspberry Pi, and I can use Node MCU or Arduino to make the sensor components, wireless sensor components. So if I'm making any sensor with a Node MCU, it will cost around 5 to 800 rupees or 1000 rupees. So that will reduce my infrastructure cost. So always it is better to take Raspberry Pi and Node MCU communicating with Raspberry Pi. So Node MCU will take up the data and share that data with Raspberry Pi. That's why I've explained you what is Node MCU and what is Arduino. So guys, I hope I'm audible and you can understand I'm not going fast. Fine. Is it audible to you all? Just please. And I hope I'm not boring you anyone. And please update me whether I'm going fast or the space with I'm going is okay. So we were at the Raspberry Pi. So Raspberry Pi started in 2012 and the latest version is 4, that is in 2019. Okay, so this is Raspberry Pi 3B model. It is Raspberry Pi 3B model. You can see, I'll be showing you in terms of video also. So you can see there are 4 USBs over here. To these USBs you can connect keyboard and mouse. Fine, maybe wired or wireless. Okay, then one thing which you can see here on the other side next to USB is a Ethernet port. Fine, it is a Ethernet port. Fine, then there is an audio port over here to which you can connect the headphones. The next here is a camera port. Fine, there is a camera port, and next to the camera port there is HDMI. Fine, this HDMI is for monitor, and there is a micro USB here for powering it up. This is again for the display, and just below that there is a SD card slot to which I can connect 8 GB, 16 GB or 32 GB SD card. And here on the other side, these are 40 GPIOs, general purpose IO pins, which can be set as input or output. They are working with 5 volts, 3.3 volts, and they have multifunction. They can work with I2C, they can work with SPI protocol, they can work with UART protocols. Now if you see Raspberry Pi 3B plus, fine, it is BCM, it has a SoC, system on chip, with the number BCM2837. It has a CPU that is Cortex A53, which is working at 1.4 gigahertz. There is a GPU, SD-RAM of 1 GB, storage card, Ethernet up to 300 Mbps, wireless 802.11n, means it is dual band. It can work with 2.4 gigahertz as well as 5 gigahertz both. It has Bluetooth. In version 4, Bluetooth BLE 5.0 is there, Bluetooth Low Energy 5.0. It also has an audio output as well as the video output in 2 formats, that is HDMI as well as the composite and headphones, and there are 40 GPIO pins. This is what the model which will be I'm showing you the programming for. So this was a 4B. You can see the modification on 4B. These are the USBs here. This is 4 rather. Then there is a Ethernet connector. These are GPIO pins. Again, there is a display connector. Here there is one sound port, but in this there are two HDMI ports. Fine, there are two HDMI. This is C-type connector for powering it up. There is a display, and just below that you can see a black portion, that is an SD card connected. Fine. So if you have a 4B or 4 version with 8 GB of RAM, it is as good as you are using a desktop computer. But the only thing is it has limited number of resources, but it can be very nice for browsing, for listening music, for programming with C, C++, Java and Python. This is a very nice system. And the cost is even around 4,000 rupees. If you take all the accessories, it goes up to 5,500 rupees. And you can connect to keyboard, mouse and monitor. So these are the 40 pins of Raspberry Pi. Now you can see this pins properly. On the side of USB there is the highest number of pin, and exactly opposite side of USB there are low number of pins. The outer section are all even number of pins, and the inner section is all even odd number of pins. So the bottom pins are 1, 3, 5, 7 till 39, and the upper pins are 2, 4, 6, 8 till 40. Now you can see pin number 1 is 3.3 volts, pin number 2 is 5 volts, pin number 4 is 5 volts, pin number 6 is ground. So it also has multiple grounds, like pin number 6, pin number 9, pin number 14, 20, 25, 30, 39. All are, you can say, the ground pins. It has 5 volts pin. There are two 5 volt pins, one 3.3, there is another 3.3. Pin number 1 and 17 are 3.3 volts, and then rest all are GPIO pins, general purpose input output. Now GPIO 14 and 16 can be used for serial communication. If you see properly, there is written TXD and RXD. So this is the complete system. You can see now properly. Yeah, now this is a bigger version. You can see pin number 8 and pin number 10, they can be used for serial communication. Pin number 24 and 26, they can be used for serial communication with SPI protocol. SPI stands for serial peripheral interface. Fine. So this is how to this. Now I'll be showing you some demonstrations also. First I'll be showing you the code, explaining you the code, and then I'll record a video and put it in the group so that you can properly see that video. Fine. And if it is possible, I'll try to connect it live also. So this was the complete 40 pin header which I've already explained you. Now you can see how the things are getting connected to Raspberry Pi. So keyboard, mouse, Ethernet, and then you can have a SD card and a adapter. This is the complete RPi system. Fine. Now for OS installation, you can download its latest version of OS from raspberrypi.org. Now you have two types available. One is Raspbian and other is Noobs. Fine. So Noobs is out of the box software, and another is Raspberry Pi. And Raspberry Pi OS, that is Raspbian, and it has built-in Python, Java, LibreOffice and all those softwares which are needed. I'll be showing you each and everything. Now whenever you download, always try to download the complete package of Noobs. Don't ever go for light. Whether you're going for Raspbian or Noobs, you download the complete package because it will install without internet. The moment you go with light version, you require an internet for installation. So Noobs is 2.3 GB around software. So once you install your Raspberry Pi, the first look will be like this. I'll be showing you that. Fine. So this is how the Raspberry Pi will look like. Now what I'll do, I'll switch over the screen to Raspberry Pi and I'll show you the screen exactly what it was looking. So guys, you can see the Raspbian over here, and this I am controlling through a wireless system. My Raspberry Pi is connected with wireless point. Fine. Now you can see the Raspberry Pi screen. I hope Raspberry Pi screen is visible to all. Yes, Raspberry Pi screen is available, visible to all. So this is Raspberry Pi screen. This is the start button. From here, everything we can connect. Then this is the icon for the browser. These are folders, and this is terminal. Now in Raspberry Pi, since we are using a distro of Linux, that is Raspbian, we don't have command prompt, but we have something what is called as the terminal. So if I click this, I'll get a screen and I can practice any Linux commands. Fine. So these are the commands which you can see, the Linux commands. So now, fine. Now I'll just go through the menu fast. You can see here in this menu there is a programming. In programming there is blue Java IDE, greenfoot Java IDE. That is Node-RED. Node-RED is one of the applications which runs with Raspberry Pi, in which we do not have to do coding, but we have to do the block programming. What we have to do is block programming. After that we have Python idle. Fine, we have Python idle. And then there is a Scratch, there is Thorny Python IDE. If you go to education, there is SmartSim, one software for the hardware programming. Then in Office there is a LibreOffice, where Write is the software like Word. Graphics, in sound we have VLC player. Fine, we can play the music, we can run the audios. Then in graphics there are some softwares. The main thing is preferences. Now when I come to preferences, all the configurations related to my Raspberry Pi can be done here. Now if I go to RPi configuration, you can see some screen over here. In this screen, if I go to interface, I can see camera, SSH, VNC, SPI, I2C, serial port, serial console, one wire and remote GPIO. Now friends, whatever devices you want to enable or disable, you can do through this panel. Again, I'll repeat from where I've gone to this panel. I'll go to Raspberry Pi, and then I'll go to preferences, and I'll go to Pi configuration. Now here you can see you can have a appearance setting, you can do the audio device setting, keyboard settings, main menu setting, and then Raspberry Pi configuration. Now in Raspberry Pi configuration, it will show you the general configurations over here, whatever the host name and all what are given. Main important is interfaces. So I have, if I don't want camera to be enabled, I can make it disabled from here. SSH disabled, VNC it is enabled because I've connected through VNC. Then SPI enabled, that is serial programming interface. Then I2C is another protocol, serial port, serial console, one wire and remote GPIO. So whatever things I need, I can make it enable and I can make it disable. So this was a thing. Now just a simple demonstration for Python IDE. I can go to Python idle 3. Now you can see this is Python idle 3. Fine. In this Python, I can just write a equal to 10, b equal to 20, and if I just write a plus b, I'll get result at 30. Fine. Now if I say a and enter, it will give me 10. If I write id of a, it will tell me the memory location where this a is stored. And if I write type of a, it will tell me it's of class integer. So this way I can do the programming, I can work with Python. Fine. Even there is one more ID of Python, that is called as Thorny Python. So in that Scratch is there, Thorny Python is there, idle is there. Now I'll just explain you how I can do a LED blinking code. So I'll just I've written already code I've written. I'll just open that code. Fine. So I'll first switch over to my PPT and explain you the code, and then I'll try to give you the demonstration. Now see, I have connected one LED. Now in this diagram, I'm showing you just one LED, but in my system already I have connected 8 LEDs. I have connected 8 LEDs. Now this is what is the code. The very first line says import the package. Now import rpy dot gpio as gpio. When I say import rpy, rpy is a package and that gpio is a class, and I'm giving one name to it as gpio. So I can use this package with the name of gpio, or this class with the name of gpio. Then I'm writing import time, that is a class, because I need some delay functions, and delay functions are available in time. After that I am writing gpio. After that I am writing gpio, fine, dot set mode. Now when I say gpio dot set mode, I have to define that pin either as input or output. I have to define that pin as input or output. So here I have a setup, I have a set mode. Now in Raspberry Pi, there are some few pins which are connected to the processor directly, and there are some few pins which are available on 40 pins. So if I want to use those 40 pins, then I'm supposed to write board. But if I want to use the pins which are directly connected to the processor, then I'm supposed to write here gpio.bcm. BCM is nothing but the Broadcom. So when I write BCM, the pin definition will change. Then I've written gpio.set warning false, means it will disable all the warnings. After that I've written setup pin number 11 as gpio.out, means the pin number 11 is set as an output pin. So this was the initial part. Again I'm repeating. First import rpy.gpio as a gpio. Then I've imported a time. These are the packages. Now if you know C, this is like a header files in short. If you know Java, these are the packages and the class. So set mode will define which pins I'm using, either the Broadcom pins or the board pins. Board pins are available on the header. Then I can have set warning. It won't show any warning. And then gpio.setup 11 as gpio.out. I'm setting that pin as output. After that, now once I set it output, what will happen? My setting part is over here. Now while true means infinite loop, because my embedded system or IoT system should work for the infinite loop. Fine. So this is how it will work. And then print LED on. Now what will happen? LED will be on. This is message will be printed. Then GPIO dot output pin number 18 comma GPIO high. Fine. Now it will set that pin. Now see here I've done a mistake. It should be 11 because I've set 11 pin as the output. It should be 11 pin. I'm sorry. This is a mistake. It should be 11 over here. Fine. It will turn on the pin. Time dot sleep 1. It will sleep for 1 second, means it will hold the system in the same state for 1 second. After that it will pin the LED off, and again it will make the GPIO pin low. Low means LED will get off, and again it will sleep for 1 second. So what will happen? LED will turn on for 1 second, LED will get turned off for 1 second. So this is what is the simple code. So I hope everybody understood this code. Anyone, any issue with the code? Please let me know. If anybody wants any explanation, I'll be giving you again. If anyone needs any explanation of the code, just let me know. I'll explain you again. Yes, anyone? Fine. So what I'll do, I'll switch over to my Raspberry Pi and I'll execute this code. So I hope this code is visible to everyone. Here I've changed the pin number to 3 and I'll just run this code. The moment I run the code, you can see that is LED on, LED off, LED on, LED off. So now friends, just give me a moment. I'll try to connect my camera and show you the LED if it is visible. Yes, I can show you the LED part, just a moment. See, the LED is blinking, is visible over here. This is what is my Raspberry Pi setup. You can see here. The code is executed over here. It is running over here. And this LED is blinking. So you can see the LED blinking here. I hope it is visible to everyone. Yes, it is visible now. And now what I'll do, I'll change the program. You can see here for a pattern generation. I'm just giving you another demonstration where I can generate some LED pattern. I'm running one code in which some pattern will be generated on LED. I'll show you those patterns also. So right now the pattern is all LEDs are blinking. So you can see all the LEDs are blinking over here. And these LEDs are connected to Raspberry Pi. You can see from here. These all are connected to Raspberry Pi. And this Raspberry Pi is connected to internet with the help of this cable. You can see the cable over here. And this is my touch screen for the Raspberry Pi red, which is there in the red color. Fine. And see all these LEDs are blinking. You can see this. Now I'll show you one more program of LED blinking. I'll share all this code with you in the group. See here, 4 LEDs are getting blinked. So I'll show you that also. Just a moment. Just you can see LEDs are blinking. Now to this LED system, I've connected one PIR sensor. Fine, this is PIR. Now this sensor basically sends the warm body basically. It sends the warm body. This is PIR sensor. I'll be showing you in the presentation. So this is my LED blinking program going on. And this is a complete Raspberry Pi setup you can see. And this is connected wirelessly to my desktop. With the help of wireless system, it is connected to my desktop. This is the LEDs which are blinking. So you can see the complete system. And here I have connected one PIR sensor. Fine. So this is the complete setup. We'll move towards the presentation. Fine. I hope guys you have seen the presentation properly. I'm sorry, the output. So I have just demonstrated how I can connect LED and blink it. Fine. Now just I'll explain you. Fine. Now what we will do, we'll see how I'm interfacing the sensor. Now you can see the PIR sensor which I have shown you. Fine. And a LED I have connected. Now for a PIR sensor, there is red wire for VCC. This black wire is the ground wire. And yellow wire is the wire which is given to the Raspberry Pi. After that, I have connected a LED. Fine. I have connected a LED. And what I'm doing in the code, I'll explain you the code first. Now here what I did, I have taken a RPi package. I've taken a time package. Then I've set mode to board. Now PIR sensor is connected to pin number 8 and LED is connected to pin number 10. Now friends, since this sensor is the input, I have to set that PIR pin. Now see, when I write PIR, it refers to pin number 8 which is set to input. I have to write GPIO.in. After that, I have to make the pin number 10 as output. Then it will give the message initializing sensor. It will wait for 2 seconds and it will print active. And now this program is in infinite mode. Fine, it is in infinite mode. So I have to press Ctrl C to terminate the program. Now, while true, if GPIO.input PIR means I'm taking the status of sensor. If status is high, fine, it will detect the motion. it will turn on the LED. Fine. Wait for some time and again turn off the LED. Now this process, whenever the input is sensed, it will turn on the LED and turn it up. It will blink the LED rather. It will blink the LED. And when I say time dot sleep as 0.1, it is 100 milliseconds. So it will give a small flash that somebody has crossed that sensor. So this is what is a simple code. Now what I'll do, I'll try to execute that code and show you the output. Just give me a moment. I'll turn on that code. I hope the screen is visible to all. And see, right now all these 4 LEDs are on. But the moment I flicker my hand near the sensor, one LED will blink. You can see one LED is blinking. See, there is one blinking LED. You can see this. This is a PIR sensor. The moment I do some movement over here, the LED will blink. So I hope this is clear to you all how this LED is blinking, because my PIR sensor is sensing the output. So I hope everybody have seen the demonstration that somebody, now see what you can do with this. Instead of LED, if you connect a bell, it can become an untouched bell ringing system. Fine, somebody comes near the bell, it will start ringing, which is very much needed in this pandemic situation. Fine. Now friends, we have one more sensor which I'm not demonstrating this. This is just a theoretical presentation. Now in this there is a DHT11. Now this particular sensor has a built-in controller. Now it has two sensings. One is temperature and other is humidity, that is DHT11. And there is a controller on the sensor itself which will give a digital data, okay, serially out from the output pin. So what I can do is I can connect this sensor, fine, and using this Wi-Fi I can connect to the cloud which is called as ThinkSpeak. Fine. And in this hardware I've shown one more sensor, that is LDR, light dependent resistor, which will sense presence and absence of light. And when I connect to ThinkSpeak is a cloud. What will happen is I can display, see this, there's a graph shown for humidity, there's a graph shown for increase and decrease of temperature, and there is a graph for the light. So this application you can make it to sense the humidity. Now this can be used in the farms, or it can be used in any process control system. Now see, this is one of the nice example which I was telling you. So what I can do, I can take my Raspberry Pi. See students, this can become a nice project for you. I can take a Raspberry Pi. I have a Arduino. Instead of Arduino, we are using today the Node MCU. And you can connect many different devices to this Arduino. This Arduino will communicate with Raspberry Pi. Fine. This Arduino will connect with Raspberry Pi. Raspberry Pi can be controlled with smartphone Telegram app. You can directly control through Telegram. So through Telegram, I can give a message on a Telegram. I can get the data. There is an API available for Telegram. To this, I can connect PIR sensor. To this, I can connect relay board and many more things. So all using one Raspberry Pi and one node Arduino, I can design a very nice system. You can see the complete output on the screen. This can become a some project which can be used for many different purposes. Fine, this is a simple home automation system in which I have Raspberry Pi. There is no Arduino over here. This is a 4 relay board. Fine. There is a light sensor. There is a humidity and temperature sensor. There is a PIR sensor, and I have connected the Ethernet. Fine. And here there is home appliances. There are two motors and two other devices. So in this way I can do programming. Fine. So for relay controlling, relay is a digital device. You can use just high and low for controlling the relays. Fine. So I hope that's where my presentation ends. And sorry because of the delay the which we started, but then after that I think it was all okay with a happy ending. And if you have any questions, you can ask me, guys. I hope things are clear to you. Yes, Aragya, it is a Raspberry Pi kit along with the Arduino and all the sensors. Yes, guys, anyone, any issues? I hope the ending was happy with the small glitches. So if you have any issues, please just I'm sorry, any questions, just let me know. And guys, you can fill up. Yes, I hope you have enjoyed the session. Mohammad Ali, there is no simulator for Pi. There is no simulator for Pi. How do you program the Pi using wire? Means you can connect keyboard, mouse and monitor to it. I have shown you one diagram, one image. In that you can connect what do you say, the keyboard, mouse, and you can do it. There are no simulators for Raspberry Pi. There are no simulators. Yeah, to my Raspberry Pi I have connected one display separately. The connection diagram have you shown? How did you draw? I have drawn with fritzing. There is software called as fritzing. Yes, Java can also be done on Pi. Kasim Ali, Java can also be done on Pi. Aragya Chaudhary, this is a different session. The evening sessions are different. And to all the participants from the Bangalore College, I would like to tell you that yesterday my Node MCU with IoT session started. And yesterday one session was over. If you would like to join, I will share the link with Priyanka ma'am. You can attend those sessions. Those are free of cost. Fine, there are no charges. It is 7 days Node MCU with IoT. And yesterday one session has happened. Today there will be another session at 5 p.m. So even you can join that session. So I'm sending the feedback form, guys. You can fill up this feedback form. Right now I cannot explain about Java right now because fine, let me try from my end if it is possible, because I don't have any Java code written right now. So what I'll do, I'll be posting some videos, you can see in that, because I have to check whether my properly Java is installed or not. There is ID installed, that's why. But soon I will be uploading some videos how to work with Java.